What if simply typing a few extra characters could crash a program, or even let a hacker take control? It may sound dramatic, but it's a very real vulnerability, and it's called a buffer overflow. In this video, we'll guide you through the key points: what buffer overflows are, core terminology, how they work under the hood, how to defend against them, and finally, a live demonstration of this vulnerability in action. A buffer is a small block of memory that temporarily stores data, like user input. It's fixed in size and created at runtime. Buffers are everywhere in programming, and when not handled carefully, they become points of failure. Let's break it down. First, a vulnerable function like gets is called. It doesn't check how much input is being received. Then, the user inputs more data than the buffer was meant to store. This overwrites adjacent memory, including return addresses. Finally, the program either crashes or gets hijacked to execute malicious code. This isn't just theoretical. The Morris worm of 1988 used a buffer overflow to bring down about 10% of the early internet. In 2014, Heartbleed, a critical bug in OpenSSL, also involved memory handling flaws. And even today, Windows and Linux systems regularly patch buffer overflow vulnerabilities. Let's look at a simple C program vulnerable to a buffer overflow. First, we inject oversized input. Then, we observe how memory gets corrupted. Finally, the program crashes or behaves unexpectedly. A clear, visual example of real-world exploitation. We're using a C program with an 8-byte buffer and a function pointer called func, initially set to null. The gets function accepts unchecked input. On normal input like hello, the program works fine. But when we input more than 20 characters, we overwrite memory, modifying the func pointer. If triggered, this diverts execution and can crash or run arbitrary code. Open your Kali Linux terminal and create a file with VI editor named overflow.c. I am pasting a simple buffer overflow C code example. It uses a unsafe gets function to take input which do not have any bounds checking. This function have input variable for 8 characters, but can accept more, due to gets function. Now I will compile the code with GCC. Let's run this code normally first. Now let's run with longer characters and see how it behaves. What you just saw was a buffer overflow in action. The input exceeded the buffer's limits, spilling into adjacent memory and causing system instability. In real-world attacks, this could mean overwriting return addresses or function pointers, and potentially gaining complete control over the program. So how do we stop this? Educate developers about these risks. Use safer functions like fgets instead of gets. Rely on compiler protections like stack canaries, ASLR, and DEP. And implement continuous testing using fuzzers and security scanners. As ethical hackers, our job is to find these flaws safely and report them. Scan code for unsafe functions, build non-destructive proof-of-concept exploits, disclose responsibly, and help devs apply the fix. If this demo helped you understand buffer overflows better, like and subscribe for more beginner-friendly security content. Want us to cover heap overflows or format string vulnerabilities? Drop it in the comments. Stay curious, stay ethical,